Hello, geometry. We're gonna try to have the quickest video ever, potentially. All right, ready, set, go. So we're doing something kind of random. We're doing probability. Why are we doing probability? Because for whatever reason, it's a standard for geometry class. Where does probability fit? I don't know. Doesn't really fit in any subject. So let's throw it in geometry, they said. So that's what we're doing. We're doing probability today. So what is probability? Probability is a measure of likeliness that an event will occur. It is a number that falls between 0 and 1. It is a number that falls between 0 and 1. To calculate the probability in an event, you use the ratio of what you want over what you can get. Or another way to write this is positive outcomes over total outcomes. Okay? So, how many pieces of candy are there total? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. There are 11 pieces of candy. Okay? What is the probability of selecting a cherry piece? So, when I say positive outcome, or when we say what you want, we want cherry pieces, correct? So, how many cherry pieces are there? There are 1, 2, 3, 4, 5. So 5 over 11. There are 5 total pieces that you want, but there are 11 total options. So 5 out of 11. Okay? What is the probability of selecting a lemon piece? Lemon, there's 1, 2, 2 lemons. So 2 out of 11, 2 over 11. What you want lemon out of the 11 total pieces. What is the probability of selecting an orange piece? 1, 2, 3, 4 out of 11. Okay? Let's pull up a calculator and get the decimal version of each of these, because as it states over here, it's a number less than 1. Well, when you do the fractions, when you do the division, 5 divided by 11 for 5/11ths, you get 0.455. If I round to the thousands place, that 5 will round that 4 up. And 2 divided by 11 is 0.182. And 4 out of 11 is 0.367. And if you add all three of those up, 0.455 plus 1.82, oops, not 1.82, 0.182 plus 0.367, you'll see we get an answer of essentially 1. Due to my rounding, our answer was thrown off a little bit, but it essentially adds up to 1, because that would be, you've got a possibility of this event, possibility of this event, possibility of this event. Add them all together, you get 1. Okay? So what flavor has the lowest probability? Well, it makes sense that the one that has the least amount of options would be the lowest probability, which is lemon, because that's the smallest value. Lemon, that's the smallest number right there. And it has the least number of pieces, 2. Would you be more likely to select a cherry or an orange? Cherry would be the correct answer here. There are more cherry pieces than orange pieces, and as a result, the probability is bigger, right? 0.455 is greater than 0.367. What is the probability of selecting an apple piece? Well, there isn't an apple piece. There are 0 apple pieces out of the 11. So there's a 0 probability. There's that. We're going to do this in class because it involves us actually playing some rock, paper, scissors. So we'll do that later. Because there are several outcomes possible, we will draw a tree diagram to represent our game. So when we play rock, paper, scissors, this is like a little taste of what's to come. When we play rock, paper, scissors, there's one player. There's 2 players. Player 1 will play either rock, paper, or scissors. And player 2 will play, when player 1 plays a rock, player 2 could play rock as well, paper, or scissors. When player 1 plays paper, Player 2 could play rock, paper, or scissors. And when player 1 plays scissors, rock, paper, and scissors are still an option. Okay? So there are 9 variations. It could be rock versus rock versus paper, rock versus scissor, paper versus rock, paper versus paper, paper versus scissor, scissor versus rock, scissor versus paper, scissor versus scissor. There are 1, 2, 3, 4, 5, 6, 7, 8, 9 possible outcomes. How many outcomes does the game have? 9. There are 9 ways a game of rock, paper, scissors can be produced. Okay? So label the branches as for who won or tied. So it said player A. We're going to say player 1, player 2. So this is a tie. Paper beats rock. So this is player 2. And rock beats scissors. So that's player 1. Paper versus rock, player 1. Paper versus paper, tie. Scissors beats paper, so player 2 will win there. Scissors and rock wins, so player 2 wins. Scissors versus paper, player 1 wins. Scissor versus scissor, we have a tie. So how many wins does player 1 have? 1, 2, 3 wins. How many wins does player 2 have? 1, 2, 3 wins. How many wins how many ways to tie? 1, 2, 3 ties. So, find the probability that player A will win any round. How many ways can player A win? 3. And how many ways can the game end? 9. So player A wants to win. There's that want word. So that's the outcome that we want. There are 3 ways for that to happen. Out of the total number of outcomes, there are 9. 3 out of 9 is 1/3. Find the probability that player B will win any round. There are 3 ways for player B to win out of the 9. That's also 1/3. And how many ways are there to tie? 3 out of the 9, so that's 1/3. So there is an equal chance of player A winning, player B winning, or it tying. So is the game fair? Yes. There is an equal chance of winning / tying. And that's what makes the game fair. If there were more ways for player 2 to win somehow, well, that wouldn't be very fair. You'd always want to be player 2, right? Or you'd always want to be player 1. So we need the game to be fair. It is fair. Well, that's the end of that. Probability is as simple as what you want out of the total outcomes. And I just realized that I don't have a single question in this whole video, but we're only 8 minutes in, so let me make up one problem here. Let me make up one problem. Pausing. Okay, so I just typed a question real quick. There are 20 students in class, 7 are freshmen, and the rest are sophomores. What is the probability of choosing a sophomore at random? Give that a shot real quick. And some answers pop up on screen. So we know that it's what you want over the total. What do we want? We want sophomores. How many sophomores are there? Well, if there are 7 freshmen and the rest are sophomores, 13 of them are sophomores out of the 20 total students. Boom. There's your answer. Hopefully that's what you typed. That's all I got for you. Thanks for watching. I'll see you in class, and we'll play some rock, paper, scissors. All right. Peace out.